Okay. Good afternoon, Sir Lee, and everyone else that is watching. My name is Kanan, and this will be my third video evaluation in actually the 1st of October 2021. That's the date that I made it. So, in this video evaluation, there will be only two questions, and I will be only using both the I will be reading the question out loud, and I'll be showing off the process as well as explaining on how I do it. I won't be using Desmos because there is no need for graphing in this part. With that being said, we can instantly move on to the first question. Now, in the first question, it asks us to solve for an arithmetic sequence. It already gave us the term, or two terms actually, is the 43rd term is 289, and the 459th term is 5697. It asks us to determine the formula for a general term of Tn and use the formula to determine the 7000th term. Now, to do this, we first need to know the general formula for arithmetic sequence, and that will be shown as such. Tn shall be basically the general term, and A shall be the first part of the sequence, or the first phase of the sequence, N shall be the number of term, and D shall be the common difference between terms. Now, since we have two terms that we know, the 43rd and the 459th term, we can simply separate them to be different equations, with 43rd term to be zero point 0.1 and 459th term to be zero point 0.2. We can implement the general formula of the arithmetic sequence into what we know for each term, and that will give us as zero point 0.1 to be a plus 42d is equals to 289, and zero point 0.2 shall be a plus 458d is equals to 5697. After that, we can simply substitute each other so that we can solve for one of the variables. And in this part, let's just solve for d. So substituting both points together, and we shall get that is d is equals to 13. Once we know the variable of d, we can simply put it to one of the points that we have already known, so we can get a. So solving for a, as we implement d to one of the equations above, and we shall get a is equals to negative 257. Now we already know all the variables, and we can simply put as a general formula for the arithmetic sequence in this one. Simply put, we can just make as Tn is equals to negative 257 plus n minus 1 times 13. So the formula, or Tn, can be equated as negative 244 plus 13n. Now, since we already know the formula for the general term Tn, we can simply solve for the 7000th term of the arithmetic sequence. Simply so, we just need to substitute n to 7000 since it is asking for the 7000th term. Doing so, we shall get the answer of 90,756 for our final answer. Moving on to number 2. So in number 2, it asks us to solve for compound interest, also annuity for this one. The question reads as a young couple is purchasing a house for $80,000. They put a down payment for $40,000 on the house and takes out a mortgage for the rest. The mortgage is a simple ordinary annuity with regular monthly payment at 4.5 per compounded monthly. Now, the questions also ask us to find the size of the monthly payment they need to make in order for them to pay off the mortgage in 30 years. It also asks us to decide whether to use the present value or future value, so we can go into that later. But firstly, in order for us to even begin to solve the question, we need to first know the compound interest formula. And that will give us an equation of A is equals to P, 1 plus I powered by N. A will become the outputted value in the future after this entire equation. The P times 1 plus I powered by N will be solved later on. P shall be the initial payment or the initial value of the money that has been given into the formula. So it can be either the money that they stored, or basically another thing is if they pay off for the mortgage. The I stands for the ratio on how the money will grow. Basically, it means that the 4.5%, it means that the initial payment can grow in a rate of 4.5% of its value. The n as the power tells us on how long can the equation grow, or basically on how long the investment can grow. If, let's say, the n is equal to 3, then that means the the equation above, or the payment, can grow for 3 years. But this is compound interest we are trying to find about in the monthly payments, as well as it's also stated that it is an annuity. So the general term for annuity is basically like so. This is for the future value. And that is r times 1 plus I powered by n minus 1 divided by I. Now, the reason why I chose future value, or also known as FV, over present value is by two things. One, we could use the future value formula, or the FV formula, for the annuity if the question is asking to solve for a future value, or if the future value has been given to us already. It's already given to us in the form of $80,000. Another thing is that we need to solve for the monthly payment, or basically R, that the couple need to make in order for them to achieve $80,000 in the span of 30 years. So, in order to solve this, we need to first find out the values of each variables. And starting off that, we can start with, well, the simple one, and that is to find out the future value. Since the couple already made a down payment of $40,000, we can simply minus 800,000 with 40,000, and that'll leave us as $760,000 for the future value. It also stated that the compound interest, or the annuity, is compounded monthly, and the formula of I, so to be, is equals to R over the number of compound period. Now, R stands for the ratio on how the equation will grow, and number of compound period directly implies on if the compound will be, well, grow in a year, or basically on how much it will repeat the cycle within a year. Since it says monthly, it will repeat 12 times in a year. So, with that being said, I can be put into equation like this. 4.5 divided by 100 divided by 12. And that will give us the value of I as 0.045 over 12. Now, and since this is basically said that it is compounded monthly, we can just simply put the years as years itself, because everything will go off track from there. What we can do for this is to simply multiply the year by the compound period. And since it's compounded monthly, we can put it as n, and that is equals to 30 times 12. Since it says that they need to pay off the mortgage in 30 years, that will give us the value of n is equals to 360. Now, since we already get all the variables together, we can simply find the initial payment that they need to make, which is r. Putting the variables together, and that will give us into 7,600, 760,000 is equals to r times 1 plus 0.05 over 12 powered by 360 minus 1 divided by 0.045 over 12. We can simplify the following equation, and that will give us an r of 1000.81 in a two decimal place value. So, what the size of the monthly payment that they need to make for them to pay off the mortgage in 30 years will be $1,000.81. And that is the final question for this video evaluation. So thank you for listening, and I am sorry if I messed up some of the calculations, or if I forgotten to imply anything in specification. No, basically if I done goofed up. All right. Thank you for listening, and have a good day.